Okay, so let's get started. First off, I want to ask if anybody's heard of the term Dunder before. See hands. All right, so points go to whoever can count how many times I say it in the presentation, and somebody will actually probably learn a new word today at least, so you'll take something away from it. Okay, so I probably should start off with just a little bit about who I am. My name is Luke Lee. I work for an oil and gas company called Blueback Reservoir. Do a bunch of data mining apps in Python, NumPy, SciPy, that sort of stuff. Also interesting to note that I was an embedded C developer for 5 years, writing stuff for solid-state disks. So that's probably why I want to get every inch out of Python that I can. It's my background. So maybe this presentation will show you why that is. The other thing is I'm a Django enthusiast, so I kind of like to play around with a bunch of web stuff on the side, just for fun. So enough about me, why everybody is actually here. So Dunder methods, that's the whole topic today, and hopefully by the end, you'll kind of understand how they work, why to use them, when to use them, and what the whole point of them is. So Dunder is really just slang for double underscore. People just decided that saying double underscore was really annoying, and they came up with calling it Dunder. People also call these magic methods. I really hate the term magic methods. As a community, Python seems to try to discourage magic, so I think calling them magic methods kind of defeats the purpose. So hopefully by the end of all this, I'll be able to peel back some of this magic, and you'll realize there's really not too much magic to it. If you can write functions or methods, you can write Dunder methods. There's not really a bunch of magic behind them, it's just functions. Another thing is people might call them private class methods. You'll note that private is in quotes there because, as everybody knows, in Python, private and public is really just by convention, not really by language design. And again, it's just methods. The downside of them is, in my experience, I think they're pretty poorly documented. So hopefully I can find a bunch of the documentation online and kind of put this in a way that everybody can get something out of it. So I probably should have titled this talk the tour of Dunders, because really what we're going to do is it's going to touch on a whole bunch of different Dunder methods without going in depth in any of them, and hopefully somebody will pick up at least one they didn't know or something to look into later. So why is it important to know what Dunder methods are? Really, the whole point of knowing what Dunder methods are is, one, you're already using them. Whether you know it or not, you're already using them. And so you might as well figure out why, how they're being used. The other thing is it's what people like to call is Pythonic. I don't want to get into the debate on what that really means. That could be hours or a whole presentation on itself. I really just mean it to say that this is common. It's pretty idiomatic. Everybody in the community kind of seems that this is the way to do it, and in some cases this is the only way to do it. So Dunder methods are the key to a lot of different things in Python, like operator overloading. If you want to write debugging tools, you might want to do some Dunder method kind of stuff. Another really good thing for Dunders is to avoid a custom API. So when you're writing a Python method, the idea is that, or a Python class, the idea is to make your object look exactly like every other object in Python. So I want to write a class and I want it to behave and act just like any other Python object. So I don't have to teach anyone that uses my class more semantics or some other stuff. If you know how to add two numbers in Python, then hopefully you'll know how to add two numbers with my object or something similar like that. People already know Python, so don't make them learn a bunch of other stuff when they're trying to use your object if it's possible. Dunders can also be used to do some really cool stuff with DSLs. You can kind of think of this as if you're writing an ORM or something like that, you might write a DSL. So we'll first start off with the common Dunders that probably everybody's seen, probably everybody knows, but we'll ease into this tour. So the first of the common Dunders I would say is the init. So Dunder init, everybody's seen it if you've ever written a class in Python. It takes star args, star kw args, and you're in your function. You can write whatever you want. You fill out the things in your object, and you can return nothing. The next one is Dunder string. Dunder string is just another method. It's really nothing special about it. Doesn't take any arguments, and it's expected to return a string. So if I want to make the string representation of my object, I override Dunder str in my object and return whatever is useful for someone, like whatever that means. Dunder string will actually be called by Python whenever you use your object in the context of which a string might be used. So if you pass an instance to the built-in function str, Python's going to take your object, it's going to look for Dunder str. If it doesn't find it, it's going to go all the way up through the method resolution order, looking through the inheritance tree to find somebody that does implement Dunder str. And if you're a new style class, so you inherit from object, it's going to always find something. Dunder Unicode is the same thing. Whenever someone uses your object in the context that needs Unicode data, Python's just going to look for that in your object and look all the way up the inheritance stack. Dunder len, another really common one, which we'll get into a little more later, but it's like a really, I think it's a really good design. If I ever want to do, like give someone a way to see what the size of my object is or the length of my object, I override Dunder len. That's the way everybody does it. That's the only way to do it. So whenever someone calls len, the built-in function on your object, Python will look for Dunder len. So you can kind of see that all this really is something in the language. It's kind of implicitly calling these Dunder methods. So if you know what they are, and you know what the arguments are, and you know what they return, it all boils down to just writing methods. Dunder repr is another one that I think is probably, it's usually misunderstood. So it's really similar to Dunder string, but it's similar to Dunder string in that it takes no arguments and returns a string, but the kind of caveat with it is really that the string it returns is supposed to be valid Python code that would create that object. So it's really good for debugging tools like IPython or something like that, where I can call repr on an object and I get the valid Python code that would create that object, so I can copy and paste it somewhere. And I guess I didn't mention Dunder init is, like everybody knows, is probably called after Dunder new. So after the instance is created, it's not the creation, it's the initialization. So, okay, so we know there's like a couple of common Dunder methods that everybody's seen before, and now the next thing to get into is some of the cool features in the language that are powered by Dunders, which if you sat in a couple of talks today, you've probably realized these are pretty common things for people to talk about. The idea here is really, I want to show you that Dunders are everywhere. They're in the open source world, they're in the language, and they should probably be in your code too. So don't be afraid of them. So like context managers, if you want to do a context manager outside of using the decorator to create context managers, you have to know about Dunders. The collections module, there's some really cool stuff in the collections module, like name tuple, order dict. If you want to know how some of these work, you can kind of theoretically make your own examples written in just Python with just a couple Dunder methods. Properties is another really useful feature to kind of do some like encapsulation-ish type stuff, all powered by Dunders. Same thing for callables. Pickling, if you want to know how to pickle your object, there's a protocol that you override a couple of Dunder methods. Your object is immediately pickleable. Operator overloading, if you've ever done this in some other language, it's the same thing. I want to override what plus means for my operator, what it means when I add two of them or them or something like that. So we'll just kind of step through a couple of the different features, how the Dunder methods are used to implement those features, and move on. Context managers, everybody's probably heard of a couple of times today. A context manager really just boils down to two Dunder methods, Dunder enter and Dunder exit. Dunder enter doesn't take any arguments, typically returns self if you want to use it in the context where you use the as keyword. The Dunder exit has a couple of extra arguments to say what the exception type is, the exception value, and a traceback. So the idea is that if I want to write a context manager, which maybe everybody knows, a context manager really is the key to a context manager is the keyword with, and it's a way to do what I call bookended actions, something that has a very clearly defined start and end, like opening a file, opening a socket, getting a lock or a semaphore or something where I want to grab a resource and I want to release it. And no matter what happens, I always want to do those two things. So a context manager allows you to do that. And I think it was in 2.6, maybe 2.5, Python introduced the word with. With is the kind of thing that invokes context managers. So when you see the word with, when you first encounter the word with in your code, Python is going to look for a Dunder enter in the object. Then it's going to execute all the stuff in there. And then when it exits, it's going to call Dunder exit. So In 2.6? Okay, so Python 2.6 is when the with keyword was added. So what does a context manager look like? Here's just an example of one that I whipped up, like a progress bar. So say I want to show a progress bar to a user. The way a user, in my mind at least, I think progress bar starts with 0 and ends with 100. So right there we have a beginning and an end. Really good use of a context manager. So whenever I create this progress bar, I'm going to say how many items I want to process. So in this case, I want to process 5 items. So what it's going to do is normalize that 5 into something between 0 and 100 so that I can step through that. And when I invoke with, the language is going to call Dunder enter. And then when I get out of it, it's going to call Dunder exit. And what it really does is verify that when I leave the context, the progress is always 100. And when I enter it, it starts at 0. So like the first example, I say, I want 5 items. I loop through, and you'll see that it's 0, 20, 100 broken up by 5s, or broken into 5 pieces. The next one is like a good example of why a context manager is useful if you forget to do something or do something wrong. I declare the context manager saying I'm going to process 5 items, but I only actually process 2 items. Well, the context manager makes sure that I end up at 100. So I didn't forget to set the progress to 100. If I didn't do that with the context manager, I would have some try and catch around, and I'd have to set it to 100 myself. So the key here is that Dunder exit forces it to be 100. So what does this context manager look like? Dunder init, like everybody saw, is nothing special, just setting up some values. The Dunder enter is really nothing going on here except for I'm setting the current value to 0. Remember I mentioned that context managers have a defined 0 or a defined start and end. In this case, the defined start is the progress starts at 0. The end is 100. So Dunder exit, I mentioned it has a couple of different arguments. All Dunder exit does is, in this case, I'm not doing anything with the arguments. The arguments are the exception type, the exception value, and a traceback object. The exception type is if any exception was raised within the context, it's the type of exception that was raised. The value is the value of that exception, and then a traceback object. So if I wanted to handle some type of exceptions, like say I wanted to allow value errors in my context manager for whatever reason, I could handle that and then return true. And that won't pass those exceptions all the way up. If I return false, that's telling Python that I didn't handle any exceptions. If any happened, let them raise all the way up like they normally would. The update function is here. It really just normalizes between 0 and 100. So you can see that this is like a really useful language construct, and it's built in such a way that if you know about 2 Dunder methods, you can make your own really easily. And to do that, there's no magic. It's just 2 functions. The magic, I guess you could say, is that it's implicitly called. But if you look in the documentation, Python tells you exactly when they're called and what arguments they'll be called with and what you're supposed to return. So another neat feature is an ordered dictionary. Ordered dictionary comes from the collections module. It's really just like a regular dictionary. The only difference is that you can guarantee the order you loop over the keys. So as everybody probably knows, with a normal dictionary, if I loop over the keys, I can't depend on the order, which is usually not a problem, but sometimes it's really useful to be able to loop over the order in a defined order. So if I wanted to take the regular dictionary and make an ordered dictionary, there's like a couple of Dunder methods I could override to build that myself. The ordered dictionary that's in the collections module probably isn't actually written in pure Python. I'm not entirely sure. There's a link here to like a full ordered dictionary written in pure Python that you can use in Python 2.4 and back. I think the ordered dictionary may have came out in 2.5. So what are these Dunder methods here? Dunder set item is going to be called whenever the brackets, when you're indexing your item. So if I have the brackets on the left side of the equal sign and I want to set a key, Python is going to see my object and look for Dunder set item. And if it finds Dunder set item, it's going to pass me the key that they want to set and the value that they want to set it to. So that allows me to hook into the setting up of it. So if I wanted to build an ordered dictionary, the way I think of it is it's just a regular dictionary except for I know an order of the keys. So to build an ordered dictionary, I could subclass the regular dictionary and then override set item. And all I do is whenever they insert keys, just put those into a different list. So it's just a regular dictionary. I'm just maintaining a separate list of the order the keys were inserted. And then if anyone ever wants to loop over them, I can override some other Dunder methods and loop over them in that list. So like get item. Get item is another Dunder method, and it's the opposite of set item, I guess, is when someone wants to get or fetch something from your collection, it'll pass you the key. So all I have to do is override Dunder get item. Python will, whenever someone writes something with the brackets and they want to fetch something out, I just override get item, it passes me the key, and then I return the value that's at that key. Dunder len we already talked about. Del item, if someone uses the del keyword and they want to delete something from your collection, it's going to pass you the key that they want to delete. Dunder iter, if you want to make your collection iteratable, that's the iter protocol. I won't go into too much depth for that. Dunder reversed, if you want to make your object reversible. So I override Dunder reversed, and then whenever someone calls reverse on it, Python will find Dunder reversed and call that. And contains and concat, they probably aren't implemented all that often. If you want to use the word keyword, the keyword in or not in, that's when contains is going to be called. So if you look at some code and you see the word in being used, then you know that the Python is looking in that object for Dunder contains. In concat, if you want to concatenate things. So these are kind of all called the sequence protocol, and you'll hear the term protocol a couple more times, and that's really just a fancy way of saying a subset of Dunder methods that you want to override to say, I want to be this type of object. So if I want to be a sequence object, I would override the sequence protocol. And if I want to be an immutable sequence object, then I would override just get item and len, because of immutable I can't set anything. If I wanted to be mutable, I could override set item and make my object mutable. So the sequence protocol is not like all or nothing. You can kind of override what you need. So just like another good example of like a bunch of different Dunder methods to build something. And here's just an example of what it would look like. If you import the collections module, you get an order dictionary. You put things in. When you loop over the keys, it's the order that you inserted them in. And like a regular dictionary, you loop over them and it's not the same. So another really interesting language feature is properties. You can think of these as managed attributes. It's a way to attach behavior to your attribute accesses. I put here encapsulation in quotes because with properties you can kind of build encapsulation, but it's not like the encapsulation that you would think of if you come from a C++ or Java background, where it looks like it's forcing it onto you, but it's really not. Again, it can sometimes simplify your API. So say I want to have an attribute that's computed whenever someone accesses it. Instead of having a function that says that, like add these two numbers and return the value or something, I can kind of hide that in just an attribute access so that everything looks like I'm accessing an attribute, but it's really calling a function. So what does one of these look like? Here's an example of a user class. Just has a username and an email. And you'll notice, like, if you come from like another object-oriented language, you'll notice like a set and a getter function. And then this like strange thing at the bottom using the built-in property function. So the built-in property function, what it does is it takes 4 arguments. The first is a getter function. The second is a set function. Third is a delete function. I think the fourth is a doc string. So what this is saying is I have a set email and a get email, and I want to build an email attribute that whenever it's used in a get context, call the get email. Whenever it's used in a set context, call set email. And I didn't give a deleter here, but you could do the same thing with a deleter. And the way this is working is Python's going to implicitly call set email and get email whenever someone uses that email in the corresponding context. But if you'll notice here, people can still call set email or get email if they want. So, and the opposite is also true. So what it looks like if you use one, here I create a user. If you notice back here, the only caveat in the set email is that I'm like kind of doing a really lame check for whether it's a valid email or not, whether it has the @ sign in it, because I don't want to let someone set an email that's not a valid email. That's kind of the whole point of me attaching some behavior to this. So I try to create a user object. The test doesn't have an @ sign in it, so I just throw type error and saying, well, no, you can't do that. If this was for real purposes, I'd probably get a useful error message. But Okay, so, all right, I can't tell what's up there. All right, another thing is like, the next one, if I create it with a valid email, everything works. I call u.email. What u.email does is implicitly calls the get email function that we did before, returns me the email. I call set email, and it blows up and says, okay, well, I don't have the ampersand or the @ sign, so that's not a valid email. Set email, I can call it directly, so this is a difference. I can call .email because it's a regular property, but I can still call get and set email. So like, it's a little confusing here, right? Because there's like multiple different ways to do things, and as like a real Python developer, that's probably a good sign that something's going wrong. And another thing you can do here is I can still call the real, quote, real attribute underscore email. So this didn't do real encapsulation for me. I can actually set test. It doesn't actually have it's not a valid email, but I can still kind of go behind the scenes. So that's what I mean by a minute ago when I put encapsulation in quotes. It's not real encapsulation. So properties. Okay, so what's the Dunder, how does like Dunder methods tie into properties? Because we didn't see any in the previous example. Well, the way that works is Dunders are powered by what's called the descriptor protocol. Again, that's just another fancy way of saying here's a couple Dunder methods you might want to implement if you want to build what you call a descriptor. So if I want to build a descriptor, all I do is override Dunder get, Dunder set, and Dunder delete. And they react exactly like they sound, except for the arguments are a little weird. Dunder get, the first argument is instance, so that's the instance that it was called on. Owner is the class that it was called with. Set is the instance and value, and delete. I won't get into delete. Delete's kind of tricky, and sometimes it's best to not use it at all. So if I wanted to take that property built-in function before and write it in pure Python, I can make a class just to kind of show off how you would build a descriptor. So again, the Dunder init takes the 4 arguments that property function took before, the get, set, delete, and docstring. All it is 4 methods. So remember in Python, methods and functions functions are first class arguments, so I can pass them to functions and do whatever I want. So Dunder get doesn't do a whole lot, takes the same objects or arguments as before, and if they have an fget function, then I call it with the instance that it was called with. If they don't, I'm going to say, okay, well, I don't know how to read this because you didn't give me a get function. The set function, kind of the same methodology. If you give me a set function, I'm going to call it with the object that was passed in. If you didn't, I'm going to raise an error. Delete, the exact same thing. There's a reference here if you want to see like how like a full-on real property thing was implemented in just pure Python. So what does a custom descriptor look like if I use it? So say I have this descriptor called temperature, and I want to create track Celsius and Fahrenheit. So I'm going to set Fahrenheit to something, and then Celsius is going to be automatically updated. But you don't necessarily have to know that from looking at the usage. So what's going on here is I'm tying 2 different attributes together. If you update the Fahrenheit attribute, I'm going to update the Celsius attribute or vice versa behind the scenes. So that's kind of like when I mentioned earlier, it simplifies your API. So someone doesn't have to remember to call both of them, or I don't have to have some awkward function that says set Fahrenheit with this temperature, or set Fahrenheit with this Celsius value, or something weird like that. You just set it like you would think, and the conversion is kind of done behind the scenes. And it works for both of them, so either one you set, it'll update the other one. So this is powered by the descriptor protocol that we mentioned. What does it look like? I have 2 descriptors here. Celsius is a descriptor, Fahrenheit's a descriptor, temperature is the owner. It's the class that owns these 2 descriptors. So the beauty of the descriptor protocol is they're kind of like standalone objects. So I might build a bunch of different descriptors, and I can put them all in the same class. That's what I'm doing here is I'm building 2 descriptors. And you'll notice that there's nothing fancy going on here. It's just a method. So when one's used in a get context, Dunder get will be called. When one's used in a set context, Dunder set's called. So whenever I set the Celsius value, it just sets it. Whenever I set the Fahrenheit value, it looks in the instance that was passed. And now this is kind of the trick is that when setting the Fahrenheit, it depends on the instance it being passed having an attribute called Celsius, which is, again, another descriptor. So it's going to call the Dunder get on the Celsius, get the value back, convert it to Fahrenheit or return Fahrenheit or whatever the case may be. So again, nothing fancy. If like you can write a couple of methods, this is when they're called, and this is how you use them. This is the arguments they take. This is the arguments they use. So again, no magic, just methods. Everybody probably knows how to write methods, so you can write descriptors. So here's where you can start getting really crazy. If you think this property idea is pretty cool, but then you want to like take it to the limit, you can start doing some like really weird stuff. So this is like another subset of the Dunder methods where I think you can do some really interesting stuff, and this is probably maybe why they get the term magic, but we'll see. So getAttr is the first one. Just takes a name and returns, or doesn't necessarily have to return anything. It typically raises an exception. So getAttr, if you implement that in your class, it will be called every time someone tries to access an attribute in your class that doesn't exist. So if I have an object that has only one attribute and it's called ABC, and someone tries to get the attribute XYZ from that, Python's going to implicitly call getAttr with the XYZ and tell me, normally that would say, oh, attribute error, it doesn't exist. But the cool thing is it's going to call that and I get a chance to do something with it. So maybe a really good usage of this would be to maybe say, like help the user out, say, did you mean this other attribute? Like, oh, that name actually sounds like this, did you mean that? Or like maybe you could use it for some type of deprecation warnings or something like that. So there are good uses for it. And later I'll show like what we could all argue is maybe a good or a bad use, but I think an interesting one to note. So setAttr is the other one. If you implement setAttr in your object, every time an attribute is set, Python is going to call this function. So this is one where you can really mess with someone and do some really bad stuff. You can use it to implement maybe what are good things, like real encapsulation. So I could override setAttr, and maybe I want to create read-only attributes, or I want to prevent monkey patching. Like, in Python, I can stick attributes in your object wherever I want. Well, if I override setAttr and you try to stick an attribute in my object, I can raise an error saying like, no, don't do it. Which is weird because it breaks like the semantics of the language, but Python's really cool and it's going to let you do whatever you want. So I could override setAttr and say, nope, you can't set that variable. Sorry, too bad. Use someone else's class. Or delattr is another thing. Like maybe I want someone to never ever be able to delete something from my object, so I could say, again, too bad, use someone else's class. I can override that and say, don't delete this name, but you can delete this other name or something. And the last one is getAttribute. So there's some confusion between getAttr and getAttribute. getAttr, remember, is called only when an attribute is missing. getAttribute is called for every single attribute access. So anytime anyone ever tries to get an attribute from your object, getAttr will be called no matter what. And so this can be really weird, right? You can override this and like completely change the way people understand your object. That's probably why I would say don't use this, but it's pretty cool that they have it. So again, not always a good idea. The other thing to note with some of these methods is I guarantee you the first time you write them, you'll write what may be your first infinite recursion loop in Python ever. Because what you'll do is, say you'll write setAttr, and what I'll do is in setAttr is I'll say self.name equals this. Boom. Program blows up. Well, why is that? Because setAttr is called to set the attribute. So every time you call self.name, just keeps calling. You're never going to get out of there. So the trick with these is you have to actually access the Dunder dict. You have to look into the actual dictionary of the object to set them. You'll probably do that like 10 or 12 times. It's really not that big a deal. So, okay, so that's like some other like ways to take property attributes a long ways. Some other ways to do, like ways that it's used in the open source world is Peewee is a really cool little ORM that is kind of like the Django ORM. It's a really good example if you want to see how operator overloading works, like Dunder or, Dunder and. What it does is, Peewee's cool because it's only one file, less than 3,000 lines, overrides almost all the math and logic things, and it maps like logical OR to SQL OR, that sort of stuff. Pandas is another really interesting one. It's built on top of NumPy, mostly for financial analysis and that sort of thing. Cool stuff that it does is fancy indexing. So like, look at all the like really wild indexing in here. I'm indexing it with like greater than and equal and all sorts of stuff. The cool thing about this is it just goes back to that Dunder get item. So if I want to look and see how pandas is doing this, I just open up the series.py where this object is defined and go to Dunder get item and see how it works. So here's like the magic behind it is that what I didn't mention before is the key item is kind of fancy to get item. It can be anything. So this is how you implement slicing in your object, or I can index it with my own object. So you can use the type of that key item to do interesting things. So if you get a slice, you can do something, or if you get another object or something. So pandas is using Dunder GE, the greater than or equal to for that previous example, where it was greater than or equal to something. It overrides that returns a series object, and I index it with another series object. So last, here's like some ideas that I've had to use Dunders for. I decided I would make this service called Frappy that was going to be a framework for creating web API wrappers. I got tired of writing documentation for like GitHub or something, and they change the URL, and then I have to go and change my code, change my documentation, release a new version. It's all really annoying. So I wanted to see if I could write the code in such a way that it would just map to exactly what the URLs in the web worked, like how everything works, so I didn't have to keep changing my code. So like an example of how you would use it is g.users. I import GitHub, g.users, pass it octocat. The cool thing is if you look in that GitHub class, the function users doesn't exist. It's not there. It's getAttr. Someone accessed an attribute that didn't exist. So what I do is I take the attribute that didn't exist in this case, which is users, append it to a URL, and then all the arguments at the end, they become part of the query string, and then I just send you a request and it comes back. So if GitHub changes users to be coders, I don't have to change any code. You just go change your code and say change it to coders, and it works. You could argue maybe that's not the best usage, but it's pretty neat. And I override Dunder call so that you can make your object callable. You can use it in any context if there's a function. All it is whenever you put parentheses after your object, it's going to call Dunder call. So that's how the query string arguments work in. But I made a couple of mistakes. There's another really cool project. If you want to do something like this, I'd encourage you to go look at this project called Hammock. It does a little bit better job. You can chain arguments. It's the exact same idea that I had. They just do it better, and it's pretty interesting. So last, how does all this tie in with a Python philosophy? I mentioned that it doesn't have, like we don't like magic in the Python community, and then I show you magic. Kind of doesn't make sense. So the cool thing is when you're in doubt, just rationalize with the Zen of Python. Like if you open up the Python interpreter, import this, read through it, and try to rationalize what you're doing. Which, so in the face of ambiguity, refuse the temptation to guess. That means in other languages you might have get length, get size, get len. What are all those? I don't know which one to use. Well, in Python it's Dunder len. There's only one way to do it. Just do it that way. Dunder string. Do I call get string? What do I do? It's Dunder string. That's how it works. The same way with there should only be one and probably only one way to do it. Makes sense. Explicit is better than implicit. This one's kind of tricky, right? Because Python's implicitly calling some of these things. But the opposite of that is you could say, well, the documentation tells me explicitly when they're going to be called. So like I said, the key, rationalization, right? Readability counts. I think the way Python does operator overloading just looks better. I don't like the C++ or Java methods of ways that I have to put the symbols in my function names or something. I think the Dunder style looks good. And then if the implementation is hard to explain, it's a bad idea. Definitely true. Don't override get attribute. It's kind of weird, hard to explain. You'll have coworkers that will be really angry at you. But it's fun to play around with. So the end, here's a bunch of references. The magic methods is a link to a really great article describing every single magic method that's available when they're called. Code examples and sources is just a bunch of pinboard links for all the things that I read for this presentation to try to figure out what I was going to talk about, and just like interesting side notes. Presentation, the code for all this presentation is on GitHub. It's all in Markdown. It's processed by this really cool Python project called Landslide. So I write all my slides in Markdown, pass it through Landslide, and it creates this HTML5 documentation presentation for me. There's all the places that I'm on the internet. The cool thing is, like, one of them is Coderspace blog. It's a thing that came out of the Django Dash I did with some friends a couple years ago, where it's hooked into GitHub, and we blog up there, and it has a lot of GitHub integration and that sort of thing. So That's it. Any questions? What was the last part? Yeah, I mean, Dunder, I just don't like using the delete ones because I come back from a background of C, and I know that managing memory and stuff is a pain, so I just kind of like to let Python do it. What's that? No, del, I mean, I don't know. I just don't like underwriting the del items because, again, it's like one of those things where you're kind of changing the semantics of the language, sort of, and it just feels a little weird. Any other questions? Yeah.
Not a question, but a remark. I just looked at the source code of Python, and the order dictionary is actually implemented in pure Python.
Oh, okay. Right, so the order dictionary in collections is implemented in pure Python. The example I showed, it references something that someone wrote to be able to use order dictionary in like 2.4 and before. So I don't know if that's the exact code that actually got into the Python source or not. But yeah, check out the collections module. There's a lot of really cool stuff in there. Name tuple is really neat too. Default dict is another really great one, yeah.
In general, you can learn a lot of Python by just looking at the Python source code.
Right, and that's to me, the beauty of the Dunder stuff is you learn a lot about why the language does things that they do and how to make your objects do exactly what other objects do. So yeah, the idea is really just to make your object indistinguishable from a standard Python type. Then you don't have to teach anyone how to use it. Anything else? All right, thanks a lot.